PIL was synthesized by adding 5 molar sulfuric acid to triethylamine in a 1:1 molar ratio under controlled temperature conditions due to its exothermic nature. DES was prepared by mixing choline chloride and lactic acid in a 1:2 molar ratio at 60 degrees Celsius with continuous stirring. Excess water from both the solvents was removed using a rotary vacuum evaporator, and they were stored in a vacuum desiccator due to their hygroscopic properties. In this study, the delignification process is believed to follow a hybrid mechanistic pathway, starting with the protonation of the phenoxyetheryl bond, which is the most reactive site for delignification, creating a stable intermediate for the subsequent activation step. This protonation is expected to occur via proton donation from the lactic acid in DES or the triethylammonium in PIL. The activated complex then proceeds through an elimination pathway typically identified by atoms leaving the molecule from specific sites. It is predicted that a hydrogen atom and the protonated phenoxyetheryl bond are removed simultaneously, and the involved process is referred as dehydrophenolation. The mechanism is ether bond cleavage via elimination. This reaction primarily converts saturated single carbon-carbon bonds into unsaturated double carbon-carbon bonds, forming a substituted phenol. This can be characterized as typical E2 reaction, indicating biomolecular elimination in a single concerted step. The elimination mechanism is facilitated by chloride ion in the case of DES and by the sulfate ion in the case of PIL. For DES, the lactate ion forms a hydrogen bond and an ion dipole bond with the choline ion, which assists the chloride ion in initiating the elimination process.